Well, good afternoon. My name is Bruce Ladson. For those of you who don't know me, I'm with Capital Brick. We're a local brick distributor down by the Joint Base Andrews Air Force, or Andrews Base. Joint Base Andrews is, I think, is what it's called now. But anyways, we are honored to be able to come and present another presentation to you all today from Glengarry Brick. This is going to be on the introduction to thin brick, and thin brick is really coming to its own nowadays. It's used more and more, and there's a lot that are details that you need to pay attention to, and our presenter, Leroy, is quite the expert. Just want to let you know, Glengarry, if you're not all that familiar with them, they have 9 plants around the country. And these particular brick are from their Hanley plant. That's their architectural brick where they make some of the best brick in the world. And the offerings that they make are, you can get any of their colors, or from Glengarry, of any of their 9 plants, you can get practically every color in a thin brick. The difference is that you'll see in thin brick is some are extruded, or that is made as thin brick, and then others, they saw the face off. And there's advantages with some over the others. One of the advantages of sawing the face off is that if you have full brick at the base of the building, and as you get to the 3rd and 4th stories, 5th stories, if they're extruded, they may have a different shading to them sometimes. So by sawing the face off the standard brick, they're going to match, so you don't have to, that eliminates that concern. Glengarry also provides a FinTech system, a metal panel system to attach these to the building. We have those available for you for interior and exterior application. If you're interested in that, I'd be happy to bring you the small sampling of that metal panel. And if you do everything the way that the Glengarry website shows you in installing their thin brick system, they'll give you a 50-year warranty. So they're pretty confident that this system is going to last. So this is just a sampling. It's not a limitation. What you see here again is a sampling of colors. You can go to any of the Glengarry plants on the website, and if you find a particular color and you want that in thin brick, it can be done for you. And they have a variety of sizes, anything from modulars up to what they call a Titan, a 4x16, or an even 8x16. I don't know that they can do that in a thin brick though, but and anyways, we'll address that when we get to it. Okay, our presenter today is Leroy Danforth. He's just really a knowledgeable individual. I promise you, you will not go to sleep when he's making his presentation, because he's interactive. So he's going to throw questions to you from time to time and just kind of get things stirring for you. Just one thing quickly before we get into that. Just want to show you, for those again who are not familiar, this is what Glengarry, this is again from their Hanley plant, their architectural plant. This is called their clay coats. I'll be the Vanna White. Yeah, you can laugh. This is their clay coats. And one of the advantages of these is that you can get almost any color you want. So you can go to your Pantone color guide and say, Bruce, I want to see a brick in this, and I'll order it up for you. It's available in all sizes, from your modular, again, up to the larger sizes. So just want to show you that this is something that's becoming much more popular as well. It's called the Glengarry Clay Coat.
How much per thousand?
It depends, honestly, depends on the color, but I would say you would at least want to plan for about $12.50. Okay. They're on the pricey side, for sure. Okay, Leroy Danforth.
How's everybody doing this afternoon?
Great.
Good. Remember, Bruce made you that promise. I did not. So today our topic is introduction to thin brick systems. I will try and find somewhere to stand that I'm not in front of anybody. Let me see if there's another port on there. Let me stick that in the USB port there. Right on, it's over here.
There you
All right, and it even works. Okay, so how many of you, I guess, first of all, consider yourselves maybe beginner or novice as far as thin brick systems? Okay, all right, a lot of you. Okay, so that gives me an idea of how much detail to go in here. Of course, today's program is registered with AIA for 1 hour continuing education credit. The sign-in sheet here is on the corner of the table. If you need to get that, no, it'll be cool. Any questions that you have, please feel free to stop me. As we go along, you don't have to try and wait until the end. There should be, okay, somehow I missed my course description slide, but what we're going to do primarily, we'll start off talking just about thin brick and how thin brick are different from face brick. A little bit about the manufacturing. Bruce sort of led into the different methods that we can use for actually making thin brick. There are a few different ways to do it, and they certainly have some impact on characteristics, price, that kind of thing. After that, we'll begin to look at the actual systems that are used. We'll focus primarily on, I call them the site applied systems. Things that will be similar like to a stucco or an adhered masonry veneer, manufactured veneer application, you know, scratch and laugh, then getting into things like your proprietary adhesive mortar systems, sometimes they're called thin set, and then metal panel systems, as Bruce mentioned. Aside from that, depending on how time goes, how much interest you have in it, we can also get into things like thin brick with precast, thin brick with tilt up, that kind of thing as well. So here are your learning objectives. Again, shape, sizes, specifications for thin brick we'll look at really quickly. Design applications, we'll talk a little bit about where thin brick works well, where sometimes it doesn't work well, what some of the misconceptions are, that kind of thing. So you'll see that in the benefits and limitations. And we'll go over, you know, typical industry recommendations, that kind of thing as well. All right. So the first thing that we need to be aware of, we're talking about we're talking about a different kind of veneer when we talk about thin brick, okay? It's considered adhered veneer in the code. It's covered still in the veneer chapter or the exterior walls chapter, but it's, you know, independent from what we do when we stack the brick up and we use that anchors to tie it back. So we know typically anchored veneer is going to be 3 inches or more. That's our typical face brick. It can be up to 40 pounds a square foot, and we've got, you know, a mechanical connection that secures them to the back. With adhered veneer, one of the things to be aware of is there is a difference between adhered veneer and thin brick. Just like there's a difference between anchored veneer and face brick. There are many different types of masonry units that can be used for anchored veneer, different thicknesses, all that kind of thing. So when we talk about adhered veneer today, every time we say it, we're going to mean a thin brick veneer, but be aware that you could be talking about things under adhered veneer like large format tile, like manufactured masonry veneers made from concrete, even natural stone, thin natural stone veneers. That's all covered in that different section. So when you look at some of the code requirements in this section, some of the things that you'll see will relate to things like thin brick and some won't. A good example of that is the sizes of the units. You can see a 1/2 inch to 1 3/4 inches here. That's something you won't actually find in the adhered veneer section of the code. That's something that comes from the ASTM standard for thin clay brick. Okay. Anybody know how thick an adhered veneer unit is actually allowed to be?
5/8. 5/8 of an inch, right?
2 5/8 inches.
It depends on how high it is, isn't it?
Well, yes and no. Because the weight is going to determine, you know, along with your wind loads, what it's going to take to actually keep it on the building. So there's a point at which, you know, the fasteners that you use from pull out or pull through at your higher wind loadings are not going to be able to hold that veneer.
Right, but that's mechanical test.
No, that's with, well, yeah. That's another thing that we'll get into. These metal panel systems that we're talking about, even though they're mechanically fastened with screws, usually into the studs or into some type of framing, they're still covered under adhered veneer. So we'll look at that a little bit. So we'll talk about things like that as we go along. In general, adhered veneer, it's got a maximum weight of 15 pounds a square foot. And so that kind of explains this, even though the code permits adhered veneer to be up to 2 5/8 inches. Once you get more than about 1.5 inches, 1 3/4 with thin brick, you're going to exceed that 15 pounds a square foot. If you're dealing with things like cast stone, natural stone, that kind of thing, usually once you get over 1 inch, 1 inch to 1 1/4 range, you're going to be running up against that 15 pounds a square foot limit. Also keep in mind, these are all masonry substrates that we're talking about. They all absorb water, right? Which means that when they get wet, there's a saturated weight as well. That's not mentioned in the code, but it's something to be aware of. That thing absorbs water, and when it does that, that increases your veneer weight. So traditionally, as the name in here says, these types of units or these types of veneers were secured through adhesion. Traditionally, it was with a Type S mortar. If you look in the code, the only prescriptive method for doing adhered veneer is using Type S mortar. Okay, which means that everything else that we do, all your thin sets, all your metal panel applications, everything else, if it's not Type S mortar, and we'll look at the requirements in a moment, that means that it's approved by the code on the basis of testing. So basically everything else is on the basis of performance. You have to do wind testing, water testing, shear testing, all that kind of stuff. So one of the things that I like to point out about adhered veneer is that just like any other wall cladding or cladding system that we design with, yes, I like it. It has its applications. I will not stand here and try to convince you that thin brick is a perfect solution for everything, because it's not. This is a project in our area. Usually, I would say that the best solution that you have, especially as your buildings get more and more complex, is going to be a combination of different wall systems. Let each one do the thing that it does the best at. So you can see here, this is actually a combination of face brick with thin brick used in the areas where obviously you've got that cantilever there. It would cost more to do the engineering, to provide the additional steel, you know, to support that. Just some other examples, just thinking from an application standpoint, why we use thin brick, what are some of the good applications for it? In this case, this is another building that has both face brick and thin brick on it. The thin brick is in these areas right above, like here. Again, we're providing the support. Would be a little bit more difficult, a little bit more costly if that was face brick veneer. So by reducing that weight, being able to secure it directly to the wall, that makes it a bit easier. So you can see in this case, it is the same brick. They come from the same plant. And we have a really good ability to match our face brick with our thin brick. That varies a little bit depending on the manufacturing method, which we'll talk about in a moment. This is one of the more prevalent uses of thin brick now that has really helped in our industry. Most of you know, you may not do a lot of wood stud construction, but there is a height limit. You know, when you have masonry veneer on wood stud backing, it's 30 feet. Above that, you got to get creative. Me personally, you know, one of the more common solutions is, oh, well, we'll do shelf angles just like we do on steel stud buildings.
No.
Okay.
Not a great idea.
All right. Why isn't it a great idea?
Shrinkage and settlement of the wood.
Okay, shrinkage, settlement of the wood. You've got differential movement. You can usually expect about 3/8 of an inch of differential movement between the frame and the veneer, okay, if you're doing wood. So even with 3 stories, that gets significant. Here's another thing to consider. When we deal with steel, with that requirement for the shelf angles, it doesn't say shelf angles. What it says is non-combustible support for every story above that 30-foot height. Does it make any sense to connect a non-combustible support to a combustible structure? That's just the way I think. Sorry. All right. So in this case, though, this gives us the ability, if we want more impact resistance, if we want to have our face brick down at the base, we can certainly do that. We can do that up to the 3 stories. Or, you know, if we don't have the ability to support it, you know, down to the foundation, in a case like this, we can do it all with thin brick, or we can transition between the two. So it really gives us a little bit more design flexibility. Here you can see some other reasons why thin brick might be used. There is an environmental component to it. We're using less clay to produce the same amount of wall surface. If we use less clay, that means less load in the kiln, which means less fuel to fire, which means less greenhouse gas emissions. When it comes out, we've got a product now that's about a quarter. Let's call it a quarter of the thickness. It might be even less than that. Okay. So if it's a quarter of the thickness, that means a quarter of the weight on the truck. When it goes out to the job site, that weight is what limits us, not the volume on the truck, because we have heavy material. That means, you know, 1/4 of the amount of trucks going back and forth to that site to get the same wall area. Again, fuel use impacts, greenhouse gas emissions impacts from that side. So that standpoint. Obviously, don't need a lot of space on the site, or a lot less space on the site for thin brick. The structural loads are pretty, sorry.
Lesson.
Yes. That's, I don't know, it's Wednesday. Okay, so faster installation. This is another reason as well. The big impact from the installation side is if it goes up faster, that's one of the areas where potentially you see savings. So you can see. Also, it doesn't require the same mason skills. You know, a carpenter crew with some of these systems can put it up, and some of them even better than the mason crews, depending on what type of system it is. Capabilities, Bruce has already mentioned to you. Basically, we can do any of our brick sizes up to, you know, the normal ones that you use, up to your, you know, utility size. We can do corners, we can do flats. We can even do what we call end caps, which is when you need a return, like underneath, that kind of thing. Right? Thickness varies. Okay, we saw in the standard that they can be up to 1 3/4 inches. Most of what you'll find in the industry, though, is going to be up to about 1 inch, typically between 1/2 inch and 1 inch on the units themselves. Anything more than that, we usually have the capability to do, but it's not a normal thing. It's a special, typically because you want to do something like a you know, corbelling or something like that. So this is why we have different thicknesses. Okay. Bruce mentioned to you that one of the ways to make a thin brick is to actually make it thin. Not to make a face brick and then cut a thin brick out of it, but to actually make a thin thing. The tile manufacturers were really the first ones to start doing this, and so they're made like tile. The benefit is they're thinner. You usually get a really good uniform product out of it because it's a process that is intended to make thin units. Okay? When that's the case, they're usually about 1/2 inch thick. All right. We can also take normal brick production And just like we get a wire cut finish by using those piano wires and shaving off, you know, the edges, we can take a wire and drop it a 1/2 inch or 5/8 of an inch down or 3/4 of an inch down on an extruded column, the way that we make face brick, and it'll separate the top off while it's still green, while it's still plastic. So that's a way also to extrude. In that case, we can take all of that other clay material, it's perfect clay material, it just goes back into the cycle and gets remade into more brick. So those can also be done at a 1/2 inch from basically a face brick process. Okay. So some manufacturers can do that. Aside from these two methods, everything else, which is most of your industry, they have to make face brick, they fire the face brick, and then they cut it to get you the thin brick. The reason why is because most of the industry was, you know, they're face brick manufacturers. That's what they make, face brick. So usually those are going to be about 3/4 of an inch. If you get into your handmade units, you know, now you're talking a lot of relief, a lot of texture, distressed edges, that kind of stuff in the face. And so to make sure that you got a minimum, you know, overall thickness, those are going to be cut at about 1 inch. All right. There are some limitations to these different methods. Everything can't be made as a 1/2 inch tile. Okay. For example, molded brick. You know, they're not even extruded to begin with. So all of your thin molded brick, they're cut. Another example would be things like clay coats, glazed brick, that kind of thing. The way that a face brick is, usually those types of coatings are applied from the top. This is an example of one of our, the brick that Bruce mentioned from our Hanley plant. So this is actually how our thin brick is manufactured. It's a vertical extrusion. And this is actually 4 units. 2 on this side. You see the kerf in the middle, 2 on this side. That part we knock out and it splits. And it gives you that key texture on the back. But because it's a vertical extrusion, that means a glaze or spray coating would run down. Okay? So this is the kind of thing that right now we're only making in smooth wire cut type finishes. So that explains why, you know, some of the different reasons why one might be a 1/2 inch, one might be 3/4, one might be 1 inch. Why I want this brick, but I can't get it that way. That gives you some insight into all of that. And of course, the more times we have to touch it, the more we have to do to it. That's usually reflected in the price. So for example, the most expensive thin brick that you're probably going to find is going to be a thin glazed brick, just like a thin, or just like a glazed face brick, except now we got to even cut it. All right. So the manufacturers that have the ability to make a thin brick like a tile, usually you'll find that you'll see that reflected in the cost. It's also the most economical way to make a thin brick. All right. So that's that. This is an example of one that's cut while it's green. And in this case, we don't separate it. We actually fire the whole thing. This is from one of our plants. Because we have a source, they actually want this material. Pitcher's Mountain. Mm-hmm. Yeah, they recycle it in the Pitcher's Mountain. So, yep. So because of that, we don't, you know, we don't use that material. We go ahead and fire it, and then they come and get it. All right. So again, all the types of face brick we can do. We can do handmade. We can do machine or, oh yeah, machine molded. We can do extruded. We can do glaze. We can do the clay coats. Jump across that so we can get to some other things. So any questions just about the thin brick before we get into the installation systems? Okay.
Is there a height limit to putting it on without mechanical fastener?
There is not a height limit in the code for how high you can go, like there is with, say, anchored masonry veneer. What it comes down to, though, as far as your height limit, usually what's going to dictate it is your wind loads, because your strength has to be enough that under whatever that level of wind load is going to be, that it's got to be able to keep it on the building. So, yeah, there aren't any prescriptive requirements. Again, keep in mind, the only one that's actually listed in the code and it tells you what to do is that Type S mortar. And so it just says it has to have, for example, a shear strength of 50 PSI. And that's all they tell you. Everything else, though, usually they've done testing. They've had to do the wind load testing anyway. So they typically will have a chart, or at the very least, they can tell you, we've tested it up to, you know, this pressure. And you can use that to determine, okay, what's my allowable height in a given location.
Who does that testing?
I'm sorry?
Who has done that testing?
I'm not sure.
Who did the testing? I mean, the
Independent lab.
Association or
No, independent labs. Because all of those types of products and systems, they're all proprietary.
Yeah.
So they'll go and they'll get it done in an independent lab.
But we could ask you to give us a test.
Absolutely. Okay. So installation systems. One is going to be precast or thin brick face precast. Tilt up, which of course is from the concrete standpoint and the pouring, and that is going to be similar. Of course, you know the difference between precast and tilt up. We have panelized methods that we can use. These are panelized prefabricated stud panels. So again, in this case, you know, similar in some ways to precast, the way that they're erected, some of the benefits, we'll talk about that. And then the site applied methods, which are the most common, and that's where we'll start and where we'll spend the most time. So basically what we have is what we call a lot thick set, which is like your stucco manufactured masonry veneer method. Type S mortar, stick it in there, scratch coat, lath, setting bed. So that's your thick set. It can be done over masonry or concrete backup. It can also be done over frame walls, but it's a little bit different. Then you've got the next evolution, which was kind of your proprietary adhesive mortars, really aggressive grab, but instead of something that's about an inch thick, now you're talking about maybe a 1/16 of an inch or an 1/8 of an inch thick. So again, those can be done over frame walls or masonry concrete. And then you've got your metal panel applications, which we'll talk about. Again, they can be done over frame or masonry concrete. So here's an overview of the thick set method. Like I said, in the code, that's the only one that it actually tells you what to do. It's prescribed. Basically what it says is you've got to have a Type S mortar bed that's between 3/8 to 1.25 inches. That's the overall thickness. Because we're looking at masonry in this case, the lath is optional. We're talking about all masonry materials here. So if you got concrete block, for example, it's got big open pores. You slap mortar bed over the top of it, you're going to get a good bond. If it's existing masonry, maybe it's dirty, maybe it has some sort of coating on it, something that might interfere with the bond, or you're not sure. In that case, you can put the lath on there. The lath is mechanically attached. What's the benefit of the lath in this system? So I got drainage over here. Anything else?
Strength.
Strength. Okay. Is everybody familiar with metal lath? Okay. So there's the lath. What it does, it basically, instead of just relying on adhesion alone, it mechanically attaches your mortar bed to the backing. And there's two types of lath. One is just a flat lath, standard lath. And they also have what's called self-furring lath. Self-furring lath has these deformations, basically pushed in every once in a while. And what that does is it makes it stand out from the wall instead of lying flat against it. Which one do you think would be recommended in the system? Okay, the expanded lath, because what that does, instead of just laying flat against the block or the substrate and your mortar going over the top of it, it sits kind of in the middle. It makes sure that it keys in. So when you fasten that in there, now you know for sure that you have a mechanical connection. So the self-furring lath is preferred. If you use a flat lath, they also have furring fasteners. You can use a special fastener that gets that to happen. So we'll go back to this. Flashing and weeks, and this is going to be true for all of these systems. You do the same things that you would do with adhered masonry veneer. Top of the wall, bottom of the wall, any penetrations, any interruptions. In this case, you may not have an airspace, but you might have something like a drainage mat behind it.
The stucco product.
It is, yeah. All right, so if we look at this method over a stud back, one of the significant things that changes, actually, I need to go back to this. In most cases, you're going to need an air barrier in the assembly, so you're going to have something that functions as both. If that concrete or concrete masonry wall is designed and built in accordance with their respective chapters of the code, you're not actually required to have a water-resistant barrier. Okay. You're usually not going to skip that, but I point that out because that's one of the differences between when you put it on frame. When you put it on frame walls, the standard, the default is going to be that you need 2 layers of a water-resistant barrier or something that has the testing to show that it gives you the performance of at least those 2 layers. If you happen to know the ASTMs, that's D2556 Type 2. Basically, it means it has a 60-minute performance, okay? So that's important. There are some cases, and with that Type 2, you can do a 1 layer of a Type 2 water-resistant barrier, and then you can use like an airspace or a drainage mat, and you're good. You don't need anything else. So the lath, in this case, that is a critical component of the system because that mortar is not going to stick to, fiberglass face sheathing. All right. I'm sorry. I jumped. No. Yeah. Okay. So still the Type S mortar bed again. In this case, mortar additive. You can use it in the other system. In this case, it's going to increase your bond. It's going to increase your durability. The fasteners that you see there, those are just the lath fasteners. Don't worry about that. So there's a look at that system. Big difference, again, you can see is the 2 layers of the water-resistant barrier. And now that lath is a critical component of the system. So this shows a pretty typical process. In the top left, you've got your water-resistant barrier and your lath attached, your scratch coat going on down there at the bottom. Top right, it's being deformed. And in this case, down in the bottom right, he's not actually doing a mortar bed on the wall, a bond coat. He's just back buttering the units, and then he'll apply it in there, and that's an acceptable method. Pretty simple. This is the installation method that relies the most on, the mason's skills to keep everything level, to keep everything plumb. Keep in mind, your backing matters. This is one of the differences between the system. How flat your substrate is. In this case, you got roughly an inch or somewhere thereabouts of mortar that you can actually make up, any small variations in the plane of the substrate. With some of the other methods that we're going to talk about, you don't necessarily have that. Any questions about fixed set?
Keeps water from getting behind it, freezing and popping the brick.
Prayer.
But we never use it in this climate. I was about to say the same thing. Like this method is why we were always so reluctant to use it when it's full of stories up in the air and worrying about it popping off and hurting somebody. So we only used to use this when something was turning back over a roof before the mechanical attachment.
You see it a lot in one-story retail.
Yeah, exactly.
Yep. It is the most widely used method. It's the most widely used method because it is the most economical method. It's the cheapest one to do. But like you said, and it's been done for a long time, but you know, we've probably all seen, or if you haven't seen one, the rest of us could probably easily go and show you where there's a failure of this system. When it's done right, it can work, but there are a lot of things that can go wrong in that system. The standard at this point, we didn't show it in here, would be if that system is done, at this point, there's almost always a drainage mat behind it. So at least if the water gets in there, it has an opportunity to drain out, to dry out, and reduce the potential for freeze thaw and that kind of thing. All right. Other questions on thick set?
Is there a minimum clearance to grade?
There is, and it's not just with thick set, it's with any adhered veneer, okay? Doesn't matter what your masonry unit is, it doesn't matter what the installation system is. With any adhered veneer, 4 inches to earth, 2 inches to paving, I would also say 2 inches over a roof line. And if they've got another thing in there, if you've got paving or that's on the same foundation as the wall, then they say you can go to within a ½ inch. But usually we're going to tell you not closer than 2 inches. Okay. 4 inches if it's earth, 2 inches if it's paving. All right. Other questions? Okay. So thin set. Thin set is just what it sounds like. In this case, it is a mortar system, just like the thick set, but it is a proprietary adhesive mortar. It's been chemically enhanced. It's actually pretty cool stuff. If you've never seen one of their demos, they can literally trowel this stuff on the wall, pick up a block, and press it in, and it'll stay on the wall. Okay, very aggressive grab. Limitations of this system, number one, it's very thin, so your substrate has to be flat. If you're doing something like one of these architectural units from Hanley and it's nice and smooth, and you've got something that's got variation in the surface, it's going to show up. You're going to see it. In that thick set system, that lath, it's basically reinforcement. It helps to prevent cracking. That's not what it's there for, but that's one of its other functions. So in this case, you don't have that. These mortars, they are flexible, but you better get your detailing for movement right, because you don't have that that lath in there to kind of bail you out and help to resist the cracking from the truck. This system, up until relatively recently, this used to make people cringe because it's very thin. So to talk about doing this on an exterior where you're subject to those wind loads, where you're subject to that water and that freeze thaw, most people in the masonry industry would not recommend this system for an exterior installation until a few years ago. What's changed primarily is two things. First of all, you will not see anybody recommend this system anymore for exterior without cement board as a substrate. All right. The mortar itself, it bonds well to it. Plus, it's obviously a little bit better as a backing than having something like a, gypsum sheet. Aside from that, that's the critical thing. If it's exterior, it needs to be over cement board with this system. In addition to that, you can see you can put a drainage mat behind that as well. So looking from the inside out, you got your studs and your sheathing, your air and water barrier, drainage mat being optional, your cement board, and then this is basically your thin set mortar system here and your masonry units. So in that case, it's replacing the scratch and the lath, does the work of everything.
Any water getting in there gets into that green. Yeah.
And with the cement board, that's going to be taped. You see it says waterproof coating there. That's usually a part of these systems. So the seams in the cement board, they'll be taped, and then they'll have another coating that goes over there.
How does sorry, you're asking the same questions, we'll vocalize it. How does the water get through the cement board then to get to the drainage layer? Okay.
It shouldn't, but if it does.
It's not gonna do much.
Yeah.
Well, no, it keeps it together. So- No, but you won't want it to prevent it.
Yeah, but
Yeah, you
want
want
that,
it
but you want the water to,
Yeah,
you want it behind the.
Right, yeah. But it's right. That's why I didn't, taping it was the surprise. It had a lot of cracks.
61 and 63, both waterproof membranes, or what are they?
Well, like I said, this, remember, these are proprietary systems. So in some of these systems, this is actually, yeah, it's a part of the system that's applied there.
Yeah, and then you got another one at 61.
Yeah, this is just your, your typical, air and water barrier.
Yeah.
So you may not, depending on how things are configured, you may have one layer that acts as both of those.
Yeah.
So going back to this, thin set installations, one of the good things about thin sets, because they're aggressive ground, I would say the thing that they excel above the other systems at is when you want to do things like soffits, overhead type installation. You'll see some pictures later when people want to do vaulted ceilings, that kind of thing. That's a really, really good application for this. I will point out that among all the systems, this is probably the most expensive system. So, if you're doing, let's say, for example, a whole interior, this is one of those cases. Maybe you use this system for the ceiling, but for your walls, you use something else. All right. Questions about thin set? Okay. Then we've got metal panels. All right. So metal panels, the default as far as your water resistant barrier is going to be the same as with the other systems. Okay. If you're over concrete or masonry, you don't necessarily need one. If you are over frame, then the default is going to be 2 layers. This is where things vary a little bit. There's a few different kinds of panels out there. One kind of panel is going to have a flat profile, okay? So if you got a flat profile panel, you're going to have your 2 layers of water resistant barrier behind it. Or your 1 layer of water resistant barrier that gives you that type 2, that enhanced performance with a drainage mat or a drainage base. Another kind of panel that's out there is something like this. So now it's creating its own drainage space because it's sitting out away from the wall. So in a case like that, now, for example, you do that type 2 water resistant barrier, you're done. You don't have to go around with another drainage mat or that. So that's something to be aware of with the different types of panels that are out there. The metal panel in this case replaces the your lath, and it actually supports the units as well. So to some degree, it replaces your mortar. But these systems still have mortar in them. So they will have some sort of a rail, either a rail or some sort of punch on here that actually supports the brick. The brick is initially put on, you'll put adhesive on the back of the brick. And that's just because even though it supports it, they're able to be adjusted to slide initially. So put adhesive on the back of there, adhere it to the panel, and then that prevents it from moving when you come back and you grout the mortar joints. All right. You always want to use the adhesive and the mortars that are recommended by the manufacturer, because these panels have different coatings on them. Some adhesives are solvent-based, some of them are water-based, and sometimes there can be negative interactions between some adhesives, some coatings, that kind of thing. So you don't want that to happen. The contractors, very often, I get them all the time, they want to substitute these. They want to substitute the fasteners. So the metal panel itself is actually screwed into the wall, and then you just put the brick on there. They want to substitute the fasteners. Keep in mind, these are proprietary systems as well. It's all based on testing. So if the contractor substitutes the fastener What impact does that have on the testing that was done and the performance? We have no idea. All we can do at that point is go by, you know, the screw manufacturer's data and say, well, you know, they say it'll do X, Y, Z, but we don't know. We haven't tested it. Okay. For the mortar and the joints, you can use a type N or a type S. You can also use one of those additives, use a modified mortar that gives you better bond, better durability. With some systems, that doesn't matter as much. You're not really relying on the mortar as much for water penetration resistance. But in others, you know, you actually do get a mechanical connection through the tie in the mortar. So in that case, you can enhance that by making the mortar better. This shows some of the different configurations. Here's one that's a rail. Keep in mind, if you've got a continuous rail, if there's not something to actually clip that brick in there, then everywhere that rail is, your mortar is not actually bonding to your brick, which means you're relying more on the adhesive. In this case, you know, these, you can see different types of configurations for a tab or support tie there.
And all these tab systems, there's only support, gravity support. There's no, they don't like it.
You can twist the
The
brass.
one shown here, yeah, there's no actual clip. With this one, these little parts right here, they can be bent down. And so, yeah, so when they're bent down, they act like a tie when you put the mortar in, which is great as long as you're paying that one guy to go and bend all the tabs down. Because the warranty for that system depends on that. There's an example of another one. In this case, because it's open, when you put the mortar in there, it grabs it without someone having to bend it down or anything like that. There's a shot of it from the back, so you can actually see how it engages the mortar. All right. So there's standard panels and there's drainage panels. One of the reasons that we're seeing a lot of this is because you can add continuous insulation into your wall without increasing the thickness of the wall. If you need 3 inches of insulation and you're doing face brick cavity wall, your wall just got 3 inches wide. In this case, you could do a 1-inch veneer, 3 inches of insulation, you didn't change your overall thickness. A couple of things to keep in mind, this stuff weighs up to 15 pounds a square foot. So when you're putting that right up against the backing, your fastener doesn't need to be that great, but when you're hanging it 3 inches off the wall, you need a more robust fastener. This is one of the things, just like with our anchored veneer, when we started making those cavities wider because we wanted to put all that mineral wool in there, and we had to do engineered fasteners or engineered anchors, the same thing happened here. At this point, as of the 2015 code, it actually has these tables in here that you can look up. They have different ones for steel and for wood. You can see the references there. But you can look at what your stud spacing is. In this case, 16 inches. Cladding weight, most of your thin brick veneers are going to be under this 11 pounds square foot number. And you can see if you've got an 18 gauge stud, as long as you've got fasteners at least every 8 inches on that stud, you can go up to 4 inches of continuous insulation. 12 inches, you can go up to 3 with a number 10 fastener. So there are some, you know, prescribed solutions at this point to make it a little bit easier to deal with that. And I think it's 1 o'clock right now, so if anybody needs to leave, I won't hold it against you. For those of you that are able to stay, I'm going to keep going. All right, we got a few more minutes. All right, so this just shows one of the panel systems going up. You can be kind of schizophrenic with them. You don't necessarily have to start at one place, end at one place. Keep in mind, even with, and this is true of all of these systems, you still have to detail for movement. You need to leave movement joints around your windows, your openings. You need to break up the facade. It's still brick. Even though it's thin brick, it still expands the same amount as face brick does.
And masons are the trades with the mason typical back bond install within your system.
Any of these systems, if it's thick set, it's probably going to be a mason. If it's thin set, we're seeing more siding installers, carpenters doing those types of installations. All right. Even some of your metal panels. And one of the thin set manufacturers actually did a study using mason crews and using carpenter crews as far as how much time it takes and all that kind of stuff. And in that study, they actually found that the carpenter crews could put their system up about 20% faster than the mason crews. It sounds counterintuitive, but what happens is if you're doing something like a metal panel system or you're doing a thin set exterior where you got to put up that cement board, all the time goes into putting up the substrate, cutting your insulation board, cutting your cement board around your openings, all that kind of stuff, cutting your metal panels, planning all that. Your carpenter crews, your siding installers, they do that stuff all the time. The masons don't really do that. Once your panel is up, once your cement board is up, that's the easy part. That part just goes. And if you've got something like a panel or one of those kinds of things, that's
So the trade systems accommodate arches. They customize the trades to handle all kind of architectural detail.
Oh, for like a metal panel system?
Yeah.
Yeah, they'll have a starter angle. Usually they'll have some sort of starter angle. So if you've got like an arch, say for example, we have a segmented starter angle that you can use so it'll curve. I would say though that in a lot of cases, especially if you want to return and you want to see brick underneath, that's one of those cases where I personally think the best solution for it is you transition from your panel system to the thin set. And just to give you an idea why, if you take this panel and the brick normally sit on it this way, you know, if you want to do a soldier, that's no problem. We just flatten 2 rows of ties and it still sits on there the same way. But when you have that arch and you want to return on the underside, that means either either your panel's going to end right there and you're going to attach a strip, basically that's on the overhead part, or you got to bend it. If you bend it and you make a return, then that doesn't do anything anymore. So you're relying really just on the adhesive bond. Okay? And you don't have a mortar bond anymore because remember, you made this a soldier. So there's little things like that. Definitely talk to the manufacturers of the panels, depending on exactly what you're trying to do, and we can tell you what the best way we think of doing it is. So then the joints are just filled with mortar. The good thing about any of your proprietary systems, whether it be a metal panel system or your thin set systems, is usually there's a lot of support. There's a warranty involved with them. You can go to the website. There's standard details, all that kind of stuff that you can go and look at for your common applications. Really quickly, I want to tell you about the prefabricated panel systems. Like I said, these are, you know, full wall assemblies that can be hoisted by crane. You know, from that standpoint, kind of similar to precast. You know, done off-site, good quality control, not as much affected by weather. As it relates to using brick with them, though, you can use pretty much any brick with these. You can see it says compatible with less uniform and textured brick. I'll explain that in a moment, but usually the way that you put the brick on these types of panels is those side-applied methods, thick set, thin set, or panel systems. So here you can see you got your sheathing back there, WRB, There's a metal panel going on. This is an example of one of these being done at a prefabricator down in Richmond. Here's an example. I pass by this exit all the time, going back and forth to our plant. 2 weeks from foundation completion to first burger. This is the prefab project. Can be done really fast. Okay. Precast and tilt up. Couple of points on those really quickly. How many have worked with thin brick face precast or thin brick face tilt up before? Okay. Give me some pointers. Give me a learning that you have from that process. Or did everything go completely smoothly?
Well, there's limitations on how projections be beyond the face of the brick. Because when they lay the brick on the panel, it's flat, and anything you add to create depth is additional charge or complexity. That was the biggest hindrance. You couldn't have any depth to the panel. It's going to be a flat panel.
Okay. Anything else?
Yeah, same
Same?
scenario.
All right.
I think it's the same project.
So you can see here, just like he says, there's a form, and then there's a form liner. And then your brick go into the form liner. What does that tell you about your brick? They actually have to fit into the form liner. If they don't fit, you have a problem. So the first thing that you want to know about any precast application for thin brick or tilt up, you always want to let your supplier know that the brick that you're selecting is for precast or tilt up. Because a molded brick, for example, I think we talked about it when I was here one time before. Molded brick tend to be a little bit more irregular, not as uniform, which means size variation is going to potentially be a bit more. There's a gap between the brick and that liner, that concrete bleeds through. Okay. Also, we're going to wax the brick if we know it's for precast. That way, if any of that concrete bleeds through, it doesn't absorb into the face of the unit, we can remove that wax later and get that concrete off. All right. How do you think we remove that wax? Or just tell me about precast in general. How is precast typically cleaned? Okay, acid, high pressure water spray. All right, high pressure, like 1,000 PSI. All right, how is brick usually cleaned? Or what types of pressures are allowed? Yeah, bucket and brush is usually recommended. Okay, so when you have thin brick face precast, typically what we're going to do, we're going to try and keep you with smooth, wire cut. With your molded brick, we usually use sand as a release agent or to give it a color, right? You know what happens to that sand at 1,000 PSI? No, it doesn't wear away. It runs away. It flies away, yeah. So that's something to be aware of. So usually it is possible to do, and we have done projects, but in general, you know, a molded is probably going to be discouraged. Something with sand coating, that kind of thing, even on an extruded brick, is going to be discouraged for these types of applications. All right, there are different types of liners. We won't go into that. Again, the main thing is the Precast Pre-Stressed Concrete Institute. They have their own standard for what they think a brick that goes into precast should be. It's different from the ASTM standard. Which one do you think the brick manufacturers make their brick to? ASTM, okay? So their requirements are actually more stringent than the ASTM requirements. So that's something to be aware of with precast tilt up. Some manufacturers don't have the ability to actually meet the dimensional tolerances that they need to for the precision with those jobs. One of the benefits of this, I think, is obviously you have reinforcing and everything, so it gives you a lot of design flexibility. Also, as you mentioned, it's an extra cost, but you can change the depth of the form, and you can do some really cool things, actually, because you can bring that depth back into masonry. and you can do things like, I know it's here, like that. Okay. That's a thin brick face precast project. Working with the manufacturer, again, this is just a quick look at another one. This project had these piers here with these reveals in them. We can help you identify where you have special shapes. You need an end cap there, so you have a brick finish there. And if you look at this, this is 1 brick long, right? So that's a thin brick. It's only, 3/4 of an inch. So rather than have a joint there, if you want that to look right, you actually have to have a special unit that has 2 ends. The only way you're going to get that is to cut it. You can't extrude that as a tie. So that's the kind of thing that we have the ability to help you with. This was a case study, 4 buildings, 4 stories. You can see multifamily here. Don't pay attention to the numbers. I think what's important here is that, from a cost standpoint, everybody seems to think initially that thin brick is going to save money on a project. That is certainly not always the case. When you look at everything apples to apples, especially if you just look at square foot install costs, because that doesn't bring these things like your freight savings, like the, less lintel, shelf angles, that kind of stuff. That's where your savings usually come in, actually, with thin brick. It's not just as it goes up on the wall. It's those things that you don't have to do because it's thin brick rather than a full face brick veneer. So those would be the potential areas. So when you have things that are, more complex, let's say if we go back to this, things that would be more complex, give you a lot more labor, take you a lot more time, a lot more steel to do. Those are the kinds of things that when you look at thin veneer, where it may actually save you some money. Otherwise, if you're just doing it to say, okay, well, we'll change this from face brick to thin brick just because we think it'll save us some money. If it's something that can be very easily done with face brick, it's probably not going to save you anything. It may actually cost you more. So again, play to the strengths of whatever the system is. This is, thin brick systems, here veneer systems, they've actually been around for quite a while. We're nearing, I guess, into the 40s, nearing 50 years we've been doing this kind of stuff. There's some really bad systems out there, and, over time things have gotten better. There's some really good systems out there too. I actually visited this project just a couple of weeks ago, and it's literally right on Lake Erie in Cleveland, and it still looks good. It's been performing for over 30 years with no issues. Obviously, if we can do all that stuff on exterior, we have interior applications that we can do as well. These photos just show some of those things here. You can see that vaulted ceiling that I mentioned. We can do curved walls. We can do some special shapes, to give you, corbels, projections, sills, that kind of thing as well. You mentioned arches. 2 engineering degrees, I might have told you this before. 2 engineering degrees, almost 20 years in the masonry industry. I'm not touching a structural brick arch. Don't even ask. If it doesn't follow those rules of thumb, nope, not doing it. I'll do that all day long with thin brick. I think it's one of the easiest ways to accomplish that aesthetic. This just shows some of the other different accent types of things. Generally, when you see this, though, this part isn't adhered. It's got a special clip or a channel, and then there's a groove in the top of the brick that holds it on. And usually anything that's more than about 1.5 inches, that's the case. It's not just adhered onto the wall. Any questions?
If you wanted to do an arch like that, would that be a fixed mortar application, or how would you do that for that?
It could be done in thick set, yeah. It could be done in any of the methods. If it's me, I would do it in thick set or thin set before I would try to do it with a panther. I think with a panel, it kind of gives you more headaches. What I would do, if I was using a panel system, is I would run the panel system to here, put my flashing there, and then do a thin set for that point. Thank you. Other questions? All right, thank you for hanging in there with me. My cards are here on the table. Bruce's are as well. Bruce, is there anything you want to add?
No, thank you all for coming. Hope you enjoyed your lunch. Appreciate your business. Thank you.